So I ran back to my office and punched the data in, and then I ran the regression line in my calculator, and it was wrong. And then I got kind of depressed because I'd have to redo everything. So I had to scope out and figure out what went wrong. What did I do wrong? Everything looked good. And I finally said what I'll do is I'll just look at a scatter plot of the data and see what happens. And I had a scatter plot of the data, and this is useful. It had all these points like this, like I expected. And then there's one up here, like that, which I typed in wrong. And what that did was it just changed the whole equation of the regression line. And of course all the summary statistics for x and y would be wrong. But what we had done to guess the equation was still okay. So I didn't actually have to do too much except redo my video about how you use your calculator to get all the stuff you might need. And the second time I did it, of course that's the one you saw, everything came out fine. So that was my short panic. Because you know what, when you're doing these hundreds of these videos, every extra 10 minutes that you waste because you made a mistake starts to wear you out. Anyway, here we are. We're going to talk about least squares lines, otherwise known as, okay, so here's what they're called. Sometimes they're called least squares lines, sometimes they're called regression lines, sometimes they're called the line of best fit. These are all the same thing. Use whatever language you like. Sometimes I'll call them least squares lines, like I do here. I'm sort of used to that. But sometimes I'll call them regression lines, and sometimes we'll call them lines of best fit. And what they do, this is the mathematics behind it. There's a way to use calculus. It's pretty fun, but we don't get to do it here. To figure out what the coefficients are to cause this to happen, to get the smallest sum of the squares of the residuals. So basically you just write down a plus bx, and you find a formula for the residuals, which you look at the predicted y and the observed y, and then you look at the sum of the squares of the residuals, which is observed minus predicted squared, and you apply calculus to that, take the derivative, set it equal to 0, stuff like that. And you can find the equations for a and b. Kind of cool. So, and then there's various ways to express those equations. First off, we just asked the calculator what they were, and we did that. And we got these two numbers. So the slope was 78.08 and the intercept was 79.30, okay. And that was with the correct values, once we got them in there, which I have written down here, I think. Yeah, so this is on my this is the sheet of paper you might have seen in my office. So I'm copying off of there. And then it turns out there's another way to get the coefficients. Instead of just punching them in your calculator, which we did to get these, you can look at some summary statistics. Those are x bar sx, y bar sy, and r and the correlation coefficient. These things here are enough to get the equation of a regression line. And sometimes you're looking at an experiment and you don't have the data anymore, but they happen to give you these summary statistics and you want the line. You can get the equation just from these 5 things, and it looks like this. So this is the line we want, the same one. And so we compute the slope using r and sy and sx. So we have those 3 in the summary statistics, so that we can do that. So we did it here. B is r, here it is. B is r times sy over sx. So I wrote them down. X bar, sx, y bar, sy, and that's what we got. Let me double check that. That's what we got in my office, so that's all good. And then we're going to use this equation to find b. Now I got 78.08 because I rounded someplace. It's supposed to, 78.07, it's supposed to be 78.08. Rounding to that 4th place could easily happen, so I'm not too concerned about that. So I'm using 4 digits everywhere, so if one of these rounded up or down in the wrong way, that might round up or down in a way we don't like. That's all right. And then we're going to use the equation that the intercept is y bar minus b x bar. So y bar, which is the average revenue, is here, 16,980 minus the slope, which we've got 7807. I'm using it even though I know it's off by a tiny bit. And then times x bar, 115.91. And we put that in there, and I get 7930.91. So these two numbers here, computed from slightly rounded summary statistics, they match up pretty well. 7930, 7807. So I was pretty pleased with that. Everything seems to be working out. And I can not have to throw all my notes away and start my life over again and get a different book for the class, all those kinds of things you might panic over. This isn't working, it's not working. Everything I know is false. I don't know if you ever had those feelings. You're doing homework and nothing's working. Same kind of thing happens here. I'm working along and all of a sudden the computer crashes and I go say, you know what, I'm just going to have to not do this. This is like too hard. But right now, it feels pretty good. And I'm going to turn off this video and we'll be back next time.